powerful your computer is because the more calculations it can do. In the early days, people had to use valves to do this, and computers were the sizes of houses to have about the processing power of a pocket calculator. Nowadays, you've got something sitting in the average house that is millions of times more powerful than those early computers. How do they do it? Well, this was the real breakthrough with silicon chip technology. And on a roughly annual basis, the power of chips is doubling. And in other words, the number of these transistors packed onto a chip is doubling. And in fact, it's getting down to the point now where we've got so many of these things packed into a chip so tightly that they're actually beginning to interfere with each other at a quantum level. So we're approaching quite quickly the point at which we're going to have to invent a new way of doing this, or a new material, because we've almost maxed out what silicon is capable of. The way the scientists do this, or the way that technologists do this, is they use something usually called photolithography. What you do is you design a mask, and this is a special layer which you put over a layer of silicon, and then you zap the silicon, and the mask means that some bits of the silicon are protected and other bits are etched, and you can cut into the surface of the silicon semiconductor to engineer these tiny circuits. And this is all done with precision lasers, which are able to operate at very, very high resolution. And it's all automated following a computer design for that mask, and you then sort of wash away the mask material and you're left with this beautifully etched surface. And you can do multiple etchings, so you can etch a layer, wash away the mask, put a new mask on, etch again, and this gives you extraordinary levels of detail. And basically, if you were to look down a very powerful microscope, you would see this amazing series of tiny circuits, which are effectively little switches that can go on and off on the surfaces of these chips. They're nothing more complicated than that. It's the technology that enables us to do this amazing etching process that's the really extraordinary thing.
And how do they get there? But are they, obviously, it can't be wire, but you'll need to be able to get to each chip. How does it transmit, back to something else? You know
yes.
What I mean?
Well, I do understand what you mean, Tony. So when they are actually designing the chip, they're not just designing the little switches on the surface of the chip, but they're also engineering in connections. So you have little bits of silicon that run to and from each of the switches to make the little circuits or wires. So you have nano-scaled wires connecting each of these things up, and they come to the edge of the chip and they plug onto a leg. So if you look at the chip, they've got these legs sticking off that plug into the circuit board. Well, they're each connected in various ways to the switches inside the chip.
Tony, thank you very much for your question. We're going to give you a breather, quick breather, Chris. Play a track and we'll come back to Dr. Chris in 2 ticks after this one.